Go to first of all just look at everywhere except the endpoints. Is the function continuous? If I look everywhere on that except the endpoints, Laura, come back. Okay, is it continuous? Yes. Then we go to worry about the endpoints. Okay, something special is going to happen at the endpoints. Okay, here's what needs to happen at the endpoints. This box here. This is what needs to happen. So copy this box down, and then let's go talk about it. Okay. So we have agreed that it is continuous on the open interval. Now we go to look at the endpoints and see if the endpoints meet these requirements here. Felix, dare you take notes? Can do two things at one time? Can do two things at one time? Read and take notes? What would we decide about your glasses? Or you got contacts? So you are doing without glasses? Oh, okay. Oh, really? Then my optometrist is going to go out of business, and I like her. My optometrist. She'll go out of business if you guys do all this stuff.
Oh, I have my nice pair of glasses from the real doctor's place, but I always take my glasses off and put them down.
Well, why don't you wear contacts?
Contacts are itchy.
I guess for swimmers, I guess it's hard.
Your eyes are so dry.
Because of all the chlorine that you have in there. Aren't you supposed? You're wearing contacts, right? So you're supposed to put those drops in there all the time, right? Yeah, you are.
If you put drops in, it makes them feel better, but it's just so annoying, constantly oh my.
Oh, you kind of streaming.
Oh.
And you don't have it scratching your eyelid just all the time. Your contacts and also
Oh, yeah. I could never get used to contacts. That's why I tried them one time, younger days. I couldn't hack it. So
It's nice when you want to wear sunglasses where you're constantly going, so you don't want to have your glasses knock them off.
But you can get prescription sunglasses.
Yeah.
They're expensive.
Yeah. And I my. You get back here.
Yeah. Okay, you guys all right on this stuff? You get it down? Yeah, Monica got it? Okay, let's go talk about the endpoints then for this function. Remember the constraints were for the endpoints limit x goes to a plus or a minus. A plus f of x was equal to f of a, right? And on the other end, it was limit x goes to b plus or b minus. B minus f of x equals f of b. So let's go answer these two questions, okay? For this guy, is this condition met? Yes? Can you guys tell me what limit x goes to a plus of f of x is approximately? Look at the scale. 1. Good. What's f of a equal to? Also 1. Okay? So this condition is met. How about the second condition at b? Is that met? Is that met? Does the limit exist? If you are going down this curve, are you going to one value? Are you going to the value that the function is at? Yes. So both these conditions are satisfied. Therefore, this function is continuous in the closed interval. Guys with me? So you look at the open interval first. Make sure there are no holes in there. I think funky is going on. Then you look at the endpoints. Okay? And make sure that the endpoints match the requirement. Guys with me on this? All right. So I gave you the theory. Now you need to go work on this problem on your own then. And, use a graphing calculator if you need to. So your graph should look like this, okay? Should look like this. This is -1 and this is +1. everybody with me on that? Should look like that. So you're going to ask yourself this question. Is this function continuous in the open interval? Do you see a break in the open interval? No. So it's continuous in the open interval. Now we need to look at the endpoints. Okay? And we need to look at this box here. Does the limit exist of this function as I'm coming from the right of, so this is A and this is B. As I'm coming from the right of A, does the limit exist? Is it equal to the function value? Yes, this is met. Do the same thing on the other side. The same thing on the other side. Does the limit exist as you go along here? Okay, what is that limit? Sorry? 0. And what is f of 1 equal to? 0 as well. Those two are equal. This condition is met. Therefore, the function is continuous in the interval. Sorry? No, this is AB. Yeah, those are your interval notation, right? Goes back to my notes here, right there. Okay, those are your 2x values, okay, on the left and the right. Okay, is everybody all right on this stuff? Monica, are you okay? Yes. Okay, I'm just picking on you because my yawn radar went off. Okay, last concept and then we are done. So we need to look at page 75, study that box on page 75, and particularly study the functions it tells you below that. Yes, it's continuous on the closed interval. Because it's continuous on the open interval, and at the ends, it matches the two requirements. Open is when you don't have open is when you got open circles at the end. Closed is when you've got closed circles at the end. Did you miss this graph that I showed you? Did you miss this graph? Yeah. So this is closed circles here and here. So then the interval would be closed. If these were open circles here and here, then it would be in parentheses rather than brackets. Okay? Okay, so let's go study this. You need to read the box on page 75. Read it and take notes on it, okay? Copy it down in your notes so that you can memorize that. And please pay close attention to those 4 functions that are stated to be continuous.